in the future, mass computing application, such as generative AI, will be widely deployed, installed in wider area of data center. So optical connectivity will be a key technology. Hi, hello everyone. I'm proud to be here on the stage. I'm Isao Yamamoto, Chief Specialist of KIOXIA SSD Division. So today, I would like to introduce our technical new challenge, optical interface SSD. Okay, let me start my presentation with this slide. So at first, I would like to share why we are developing optical interface SSD. So now we are developing optical SSD as a part of a Japan national project, which is called really long, Next Generation Green Data Center Technology Development Project. We are working cooperatively with other Japanese vendors like Fujitsu, NEC, IO, Fujitsu Optical Component, and KIOXIA. So in this project, each company are developing a new technology to contribute to improve the efficiency of data center. So as I said, in this project, KIOXIA is focusing on to develop optical interface SSD. So I think most of the people in this room already know PCIe is improving the bandwidth. And each PCIe generation, the bandwidth is going to be double. So at this moment, in the IT industry, PCIe Gen 4 to Gen 5 migration is ongoing. So in a PCIe, for the optical, so far, the electrical copper interface is majority of PCIe-based system. But the future PCIe generation, like PCIe Gen 6, Gen 7, or beyond, optical connection will be another option to compose PCIe-based interface system, PCIe as an infrastructure. Okay, so this is our prototype. We are demonstrating this in our booth. To develop an optical interface SSD prototype, we choose bridgeboard configuration. So as you see, center is our bridgeboard. It's an optical electric conversion bridgeboard. And this board is supporting a PCIe Gen 4 bandwidth. So in this, on the left side, as you see, the conventional SSD is connecting with optical electric conversion bridgeboard through a U.2 connector. So on conversion bridgeboard, you will see optical module, which is a kind of transceiver, which can convert from electrical to optical and optical to electrical. So the reason why we choose this kind of configuration. So as you know, we are SSD vendor. We have a variety of SSD family. So applying this kind of configuration, we can leverage many types of SSD to confirm the compatibility with the optical interface. So the reason we developed this concept prototype is, as I said, at first we would like to confirm compatibility of optical interface with our conventional electrical SSD. Others is we would like to discover what's the best suited application or workload for this kind of device. So as I said, we are doing a demo at our booth. In our demo, the optical SSD is connecting to host with a 40 meters long fiber cable. So with this demonstration, we would like to show two things. One is about the performance. even having a 40 meters distance from host, optical SSD can show same performance with the electrical direct attached SSD. So others is operation. So even have a 40 meters distance, converting from electrical to optical interface. But this optical SSD can be managed by software, just same as direct attached electrical SSD. So it means no extra software stack to be required. So based on this assumed advantage, this is our assumption about the advantage of optical SSD. So today's data center, thermal control is one of very critical issue. So the data center must be designed focusing on the highest thermal capacity device, like a CPU or GPU. But for the SSD, SSD has a low thermal capacity drives. So it means if the cooling system is focusing on CPU, GPU, SSD will be much cooler. So applying this optical connection, based on the thermal capacity, each devices will be installed separately. So, and this example, you will see the high temperature devices like a CPU, GPU will be centralized in physical independent location. And SSD will be installed other location. Now, each location will have a best suited cooling system. I think, based on this configuration, optical facility management, especially power management, will be optimized. So another assumed advantage is we have to, while the connection, cabling, wiring, when you are looking into the server, you will see the very big and bulky copper cable connecting from host to SSD. But if optical interface will be installed in the server, you will see the cable will be much thin and much small. So it means the system configuration work will be much easier by deploying optical interface. So other is signal integrity. Yeah, it's optical. Optical connection is much tougher than electrical interface in a very severe environment in signal. So it means optical SSD can be deployed to much severe environment in signal, like a factory or like in vehicle. So based on those assumed advantages, so for the PCIe-based system configuration, optical interface will be improve the flexibility of system design or system configuration. And this is a kind of this idea of disaggregated system. So in the future, mass computing application, such as generative AI, will be widely deployed, installed in wider area of data center. So to better manage the resources for such kind of application across the data center, disaggregation will be an architecture option. So optical connectivity will be a key technology to compose this kind of efficient disaggregated system. So with the future generation of a PCIe, like Gen 6, Gen 7, they are supporting much wider bandwidth than now. Okay, so this is the end of my presentation. As I said, we are demonstrating our optical interface SSD concept. As a demo booth is a C2. Please come and visit to see the demonstration. As I said at the beginning, we are doing this activity as a part of a Japanese national project. Okay, that's all my presentation. Thank you for listening.